first merit question. Now, I'm not quite sure about how many of you got k equals 23 for this question. 1 part C. Let's start with this one. Who got k equals 23? One person, okay? Just the one person. K equals 20. Why was it so hard? Why was it so hard? Okay. Yeah. Now, let's have a look at this then, because the question says point k negative 9, point k negative 9 lies on the line drawn through DE. Now, DE is negative 3, 4. D is negative 3, 4. And E is 5, 0. Now, K negative 9 is on that line, is on the line going through DE. So this is straight away, this is what you're meant to say to yourself. If we join D and E together, then we get this line with a certain gradient, okay? If K negative 9 is on that line, then the gradient of our K negative 9 guy to either one of these must be the same gradient. It must be the same gradient because it's on the same line. Okay, so if we've got D here, negative 3, 4, and E, which is over here, and we put a line in down like this, near enough, then if K negative 9 is, say, here, if it's on the line, then the gradient of this guy, D to E, which we can calculate, must be the same gradient from there to there, or from there to there, if you see what I mean. It must all be the same gradient. So all we do is we work out the gradient of, DE. Okay, let's do that first. That's not very hard. Rise over run. It goes from 4 upwards. And in fact, if we do the y2 minus y1 just to be safe, y2 take away y1 is negative 4. x2 take away x1 is minus 8. In fact, it's positive 8. We get negative 1/2. The gradient of DE is negative 1/2. Therefore, the gradient of our K negative 9 to either of those must be negative 1/2 as well. The gradient must be. So let's just choose. I'm going to choose E because it's got a 0 in it, which makes it easier. So if the gradient of DE is negative 1/2, then the gradient of our K something point to E must also be negative 1/2. Okay? Or, yeah, either way. So let's take the K negative 9 and the 5, 0 and write down the gradient of that. y2 minus y1. I'm just going to put an equals because it is equal to that because we've just been talking about that. So y2 minus y1, that divided by, 0 take away negative 9 is positive 9. 5 take away K is the bottom line. Okay. So what I did when I looked at this, okay, I looked at that and I said, I need a number, and you can rearrange it, do the cross multiplication and all that, but you don't actually have to. If we've got the left-hand side of our equation is negative 1/2, we want the right-hand side of our equation to be negative 1/2. If we've got a 9 on the top, what must be on the bottom to make it negative 1/2? Negative 18 even, okay? So we need this guy to be negative 18. So 5 take away what equals negative 18. That's sort of looking at it. I get 18 because 9 divided by 18 is 1/2. Okay? If 1/2 is 9 over 18, isn't it? Yeah. Negative 1/2 is 9 over negative 18, so I need 5 minus k to be equal to negative 18. Therefore, k is 23. Just rearrange it. K equals 23. That's merit for that. But it's basically saying, identify that the gradients have to be the same. Okay? Not overly difficult, but that's sort of representative of applying the gradient thing. It's not just saying, I mean, an achieved question would be, work out the gradient of DE. Anybody can look at those two and go, oh, it's -1/2 by doing the gradient thing. But to actually kick on and say, work out what point we need for k, what number we need in here for k so that they're all in a line, that's a little bit beyond the basic skill, therefore it's merit. Yep.
Isn't it easy just to keep the equation line and substitute in?
You could. I would suggest that's more work than that. Okay, you could certainly work out the equation and then substitute the -9 in and work out the k, no question. But I think that's the long way around. But yeah, you could do it.